So let's talk about a topic called VLAN or virtual LAN. So this topic is very simple and easy. We'll understand how switch works and what do you mean by a VLAN. So VLAN is something new which you guys are learning. So first understand the broadcast logic of a switch. Okay. We'll understand what switch will do if it receives a broadcast packet. And then we have a couple of labs also in this. Okay. So imagine that we have a switch. With two line means it's a switch. So the broadcast logic of a switch says, if I receive a broadcast packet, I will forward the broadcast packet out of all available interfaces except the interface it has arrived at. So this is the broadcast logic of a switch that says it. So switch is saying, if someone sends me a broadcast packet, I will forward the broadcast packet out of all available interfaces except the interface it has arrived. That's the broadcast logic of a switch. Similar way, we'll understand what is broadcast domain. Now, what do you mean by domain? Domain means how much impact is happening in my network because of one packet or something. Imagine if flood comes to my home, how much area is it impacting? That is termed as domain. Like how much knowledge you have, that can be termed as domain. People might ask you like which domain you're working in or which domain you finished college degree. So domain basically describes how much area impacted or how much knowledge we have, like that. So domain in which all nodes can reach by a single broadcast packet, it is termed as a broadcast domain. See, your hub, switch, routers, they behave differently for a broadcast packet. Let's imagine that you have a broadcast packet. Okay. And let's imagine you have a switch. This is getting a broadcast packet. Switch is saying, just now I told, right? Switch says, if I receive a broadcast packet, I will forward the broadcast packet out of all the available interfaces. So we can say the entire switch belongs to one broadcast domain or one single broadcast domain. Next is your hub. If you take a hub with single line, it's called hub. Hub says, if I receive a broadcast packet, I will also forward the broadcast packet out of all available interfaces. So we can say the entire hub belongs to one single broadcast domain. This is also one single broadcast domain. But router, when you take a router, right? In a router, if someone sends a broadcast packet, by default, router will not forward the broadcast packet out of any of the available port. I will stop it here itself. I won't even forward it. So we can tell each interface, if a broadcast comes, that broadcast will stop in that interface itself. So we can tell it has around 4 broadcast domain. Each interface is acting like a one broadcast packet. So let's understand. Imagine that we have one PC connected to one switch, sorry, hub connected to one more PC. Ping in chat, guys, how many broadcast domains we are having in this? We have only one broadcast domain. Why? Because if a broadcast comes here to this hub, it will pass through hub, it comes here. So the entire network got impacted, right? Because one single broadcast domain. So we can tell that the entire switch, this network belongs to one single broadcast domain. If you have hub connected to say switch hub, switch PC. In this also we have only one broadcast domain because if a broadcast packet comes here, this will cross this hub, this will cross the switch also. It comes up to this PC. So one broadcast impacted everyone, correct? So we can tell that this is one broadcast domain. Let me draw two more diagrams. You guys tell me in chat. PC, hub, switch, switch, hub, PC. In this, how many broadcast domains are there? Tell me in chat. Let's understand. Imagine one broadcast is coming on this port. This broadcast will cross this hub. Here it will cross him also. From here it will cross here. It will go here. It's gonna cross here. So entire network belongs to one single broadcast domain. So it is not two, it is not three. So because one broadcast is impacting everyone, right? So it will become one broadcast domain only. Let's try one more time. We have a PC, switch, 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 PC. In this, how many broadcast domain we are having? It has only one because if a broadcast comes out here, this can go via the switches because switch allow broadcast domain. So the entire network gets impacted. So again, we have only one broadcast domain. Next, talking about this diagram. See, now it is very clear that in this diagram where we have two PC and two switch, we just have one single broadcast domain. What if I want to break it into two different broadcast domain? What if I don't want him to send broadcast packet to him? Maybe he is part of HR team and he is part of management team. I don't want them to talk using broadcast packet. So in this case, what device I have to install here? What device we have to install here? We have to install a router. Easy, right? So I'll simply install one router. What if I need like three broadcast domain, one more router, four broadcast domain, one more router, five broadcast domain, one more router. Meaning, if I need more amount of broadcast domain, I end up installing or configuring more routers here, which is not feasible, which is not easy also. That is why we have a concept called VLAN only, virtual LAN. Let's understand how the VLAN actually works. It's very simple. I'll explain it. See, you take one switch. If you're connecting like 8 cables in this switch, if a broadcast comes here, by default, broadcast will go out of all the ports. Why is it going? Because, see, inside the switcher, we have one logical interface called VLAN 1. This logical interface is called VLAN 1. All the physical ports are directly connected internally to this VLAN 1. Now, because they are internally connected to my logical interface called VLAN 1, if a broadcast comes here, this is going via all the interfaces. Except the interface it arrived, it is going via all the interfaces. Now what I do, now what I will do is that I take one switch. Inside that we have VLAN 1, right? Let's draw the same diagram again. There is a switch. There was one VLAN 1 and all the interfaces are internally connected to that particular VLAN 1. Because of which only, if a broadcast is coming on this port, it is able to go via all the available ports. Now what I will do, I will disconnect these cables internally, I'll remove them, and I will configure a separate VLAN called VLAN 2. And I will internally connect all these cables like this. So logically, we'll use commands and all to connect them. Now tell me, if a broadcast comes here on this port, will it be able to go here or not? Yes or no? So simple answer is no only. Correct. The answer is no, because they can't go. Why? Because now we have divided them into two different pieces. See, by using a VLAN, I was able to divide one single broadcast domain of a switch into two pieces of the switch without using routers. And that's the use case of your VLAN. VLAN in one line, if you ask me definition, it is used to break the broadcast domain of a switch. So in this example, if you carefully watch, here we got FA 0/0, here we got 0/1, then 0/2, 0/3. I can tell 0/2, you are part of VLAN number 2. 0/3, you are part of VLAN number 2. So that from here, the traffic will not go here and all. Easily we can fix it. Now, how do I configure VLAN? See, the configuration part is very simple. It is not even a hard part. You have to simply go to configuration mode and type VLAN 2. This will enable VLAN 2. VLAN 2 is configured. That's it. Optionally, if you want to give a name for that VLAN, you can give the name for the VLAN by typing name and give any name, XYZ, manager, Vishnu, whatever you want. So that's the simple command to enable VLAN 2 on the switch. See, once you enable VLAN 2, you have to manually go inside interface, in these interfaces, and tell, hey, interfaces, moving forward, you access VLAN 2 only, not VLAN 1. You have to manually tell them. You have to manually tell them that moving forward, you have to access VLAN number 2, not 1. But for doing that, simply go inside configuration mode and type interface FA0/3. and type switch port access VLAN 2. Then go inside 0/3 it is, 0/4 it is. Then go inside interface FA 0/4 and type switch port access VLAN 2. That's it. If you type this, the command is going to tell that you should be part of VLAN number 2, not 1 anymore. So they automatically shift from VLAN 1 to VLAN 2. See, remember one thing that one port cannot be part of two VLANs and all. Okay, one port means one VLAN. That's it. Let's understand why do we use VLAN. First of all, it reduces the CPU overhead. It has a flexible design because I'm going to divide my entire switch into different VLAN blocks. So it will be getting a flexible design only. And it is ease of troubleshooting. I can troubleshoot more easily. Because if one VLAN person says I'm unable to go online, I will check only that computer, that VLAN PCs and all. I will not look into all the PCs or all different VLANs and all. Next is your creating a multi-switch VLAN trunks. So I'm going to ask you guys a simple question. Try to answer this. Imagine that we have a switch here. It is connected to one PC. It is connected to one more PC. He is part of VLAN number 10. He is part of VLAN number 10. Can PC1 ping PC2 or not? Can PC1 ping PC2? %90 people normally go wrong here. The answer is the traffic will not go. Why? Because, see, as I informed you, by default, all the ports are part of VLAN number 1, right? Meaning, this is also VLAN number 1. How VLAN 10 traffic will go to VLAN 1? It won't go. As I informed you already, between two different VLANs, traffic movement will not be there. So in that case, to fix this problem, what I can do best, I can simply create one more link and I can configure it as a VLAN 10. I can add one more link. I can tell, hey, you are part of VLAN number 10. If I tell that, then the traffic will come here. It will go through VLAN 10. It can go. Now, what if I connect one more PC here and here, and I configure that PC to be part of VLAN number 20? Can they ping each other? Is it possible? Again, the answer will be no, clear no, because I don't have a link here to carry VLAN 20 traffic. In that case, we will be connecting one more link. I'll make it as VLAN number 20. Now the traffic can come here, nicely it will go through him, it will come here also. So the problem is solved. But what if I got like 30, 40, 50, 60, 70, 80, 90, and I have hundreds of VLAN. In that case, I need to connect hundreds of links in between them, right? Which is not feasible. Which is not feasible. So in that case, what I can do is that I'll make them as a trunk port. I can simply make one link and I can configure those port as a trunk link. So trunk is not a special port and all. It is same RJ45 port. It's just that Like we are configuring one port as a VLAN port, right? Here we are configuring it as a trunk port. If you configure a port as trunk port, that trunk port can send and receive multiple VLAN traffic, unlike your access port. Now, how can I configure a port as trunk port? I can simply do that by going to the specific interface on both the sides and typing switch port mode trunk command. Okay. Now we have to configure that port as a trunk port. How do I configure a port as trunk port? It's very simple. Go inside that port and type switch port mode trunk. Trunk port means it can send and receive multiple VLAN traffic. If we say access port are the port which can carry only single VLAN traffic. They cannot carry multiple VLAN traffic and all. Okay. Let's understand the VLAN tagging concept. It's very interestingly topic and also easy to understand. See, imagine that we have a PC called in VLAN 10. If this PC sends a traffic and we have VLAN 10 across different switches also. So then the traffic has to go through trunk port, right? It comes all the way to switch 2. Now, how does my switch 2 will come to know that VLAN 10 PC has sent a traffic? If my VLAN 10 PC sends simply a data, he received data. Now, how does he knows that this traffic is for VLAN 10 or VLAN 20? It is for whom? He don't know, right? He don't know simply. So that's where your trunk port will do a smart work. What trunk port is telling, if any traffic comes to me from any VLAN, apart from native VLAN, I'll teach you what is native VLAN later. The trunk port says, if I receive a packet from any VLAN, apart from native VLAN, I will add the VLAN tagging on top of that data packets. So that when it travels and goes to the neighboring switch can understand that this is for VLAN 10, this is for VLAN 20. Like that, they can understand it. If you don't tag it now, and all will come as a plain data packet, then switch to might shuffle the packet to VLAN 20 to VLAN 10, 10 to VLAN 20, like that. It will go ulta ulta. That's a problem. And that is where VLAN tagging comes to a picture. See, VLAN tagging plays a very important role and it does automatically only, nothing that we have to configure it. So trunk will do VLAN tagging here and they get untagged here once my switch to finds out that this traffic is for specific VLAN. Okay. So normally these VLAN informations will sit here in this place, you can see. So in the data header, it sits after the source address. This is called as your MAC header. MAC header basically consists of your destination MAC address, source MAC address, type, data, and FCS. And VLAN basically comes here. There is one small tag will get added here, which was not there before. And this small tag called 802.1Q. Inside 802.1Q, we got type, priority, flag, and then we got the VLAN ID. And normally the VLAN ID is of 12-bit value. So the range will be up to 4096. See, we cannot use all the 4096 because there are some reserved also, like 0 and 4095. It is reserved. 2 to 1001 is normal. 1 is normal, but by default it is used by the switcher. All ports are part of VLAN number 1 only. 1002 to 1005, again it is normal. 1006 to 1024 is reserved. 1025 to 4094 is also reserved. Please write this down, everyone, clearly, and try to by heart or mug up it also. Okay, done. So next is your native VLAN concept. What do you mean by native VLAN concept? We'll understand that. Just give me 2-3 minutes, I'll come. Okay. Yeah, sorry for delay, guys. Let's talk about what do you mean by the native VLAN concept. See, let's take a look at this. Imagine that you live in India, like we are living in India only. So in India, do we need passport to survive? No, I don't want passport to live in India because I am a native person. I am native to India. So in this case, similar way, by default, all the ports when their switch is manufactured now, by default, all the ports of that switches they are part of VLAN number one by default. And if VLAN one traffic is coming, I need to go through trunk port. If you try to tag, untag here, all the different ports here, maybe I'm having 40 ports. If all 40 ports are sending traffic on VLAN one, if you tag here, if you untag here, that's gonna consume a lot of CPU resource. Imagine like this: you have a very big water pipe which used to send water. Now we are inserting two more small pipes for sending maybe like oil or something like that. It is not mandatory for me to put one more pipe to send water separately, right? because anyway these two pipes are secure. If I send water through the remaining space, they can still travel. Same way, I don't want to tag native VLAN traffic because it's simply there are all interfaces by defaults are part of native VLAN only. So without native VLAN or without VLAN, if switch B receives the traffic, switch B will believe that hey, I got a traffic without native VLAN in it. I believe it is for my native VLAN. And it will send it to VLAN number 1. So that's how it works. So by default, VLAN 1 is native VLAN. So you guys tell me, if I say VLAN 1 is native VLAN, you see, we can change it actually. If you want, I can change it. You can tell me in chat. If traffic comes through VLAN number 1, will it get tagged or not here? Yes or no? Considering that my native VLAN is 1, it won't get tagged. How about VLAN 10 sends traffic? It will get tagged. What if VLAN 20 sends traffic? It will get tagged. Let's take a second condition. If I tell if I tell my native VLAN is 20, if VLAN 10 traffic comes, will it get tagged or not? If my native VLAN is 20, if PC1 sends traffic, it will get tagged. Yes, because PC1 is no more native VLAN. My native VLAN is this guy only. When he sends traffic, it will be tagged. But when VLAN 20 sends traffic, it will not be get tagged. As I informed you, native VLAN traffic will not be tagged. Let's try one more time. I know it's kind of a hard topic. So let's try one more time. See, as I informed you, native VLAN will not get tagged in my trunk link because by default, VLAN 1 is the native VLAN. If I want, I can change it. See, if native VLAN need to tag means, imagine that I have 40 port switch here and 40 port switch here. When all traffic comes here through native VLAN 1 only, all will get tagged here and tagged here. That become lot of mess. So what I'm telling is that native VLAN traffic, I no need to tag at all. If I don't tag them, they will come untagged only. If switch B receives untagged frame, he will think it is for its own native VLAN. And we can change native VLAN also. Like VLAN 10, if I make it as native VLAN, here also VLAN 10 is native VLAN. So VLAN 10 traffic will not be tagged here, but these guys will be tagged. Please remember that Cisco says if you have two connected switches, the native VLAN has to be same. You cannot keep two different native VLANs there. The native VLAN concepts has to be same between them. Okay. And please note that in a single switch, only one VLAN will be native VLAN.
That recording continue.
Sorry for that. So let's understand next the okay. Now we'll go with the lab part of it. So I'll simply show you the lab. The labs are very simple. We just need to configure one or two commands for lab to work. Okay. Fine. So now to perform this lab, what I will do, I'll take one PC and let's take up one switch. We'll take one more PC, one more PC, one more PC. Fine. So here I'll show you the simple VLAN lab. This is a simple VLAN lab. Let's connect them. On top, I will tell it's VLAN 10. On bottom, I will tell it as VLAN 20. Two different VLANs. So in this place, I'm going to use IP address 10.1, 10.2, 10.3, 10.4, or make it as 10.1, 10.2, 10.3, 10.4. To configure IP address, click on this, click on desktop, IP configuration, and type here 10.0.0.1. That's it. Same way, 10.2, meaning odd to odd ping will work, even to even ping will work. See, by default, if you want to check if the ping is working or not, I can go to my PC 0 and I can type ping space 10.0.0.2 and the ping is working. Okay. 10.3 also will work. Everybody will work. Just for your understanding, I configured 10.0.0.1 here. I've configured 2 here, 3 here, and 4 here. This is what I have done the configuration. Okay, the ping is working. Now what I will do, I'll go to my switch and I will show you the VLAN number. Type enable and type show VLAN. If I type show VLAN, it will tell that all the ports are by default part of VLAN 1. Here you can see I typed show VLAN. All the ports are part of VLAN 1. All the ports. This is called default VLAN. Now I will tell FA0/1 and 2 part of VLAN number 10. So to do that, first you go to configure mode and type VLAN 10. This will create VLAN 10. I'll say VLAN 20. This will create VLAN 20. See, you simply type VLAN 10 and VLAN 20 in the configuration mode. That will create those VLANs. Now, if I type show VLAN, I can see in the Excel sheet, it's Excel format only. I can see a column like VLAN column, name column, status column, ports column. I can see VLAN 10 and VLAN 20. Both are done. Both are done, but I don't see any active ports here. Now I want to make the FA0/1 and 0/3 part of VLAN number. FA0/1 and 2 part of VLAN number 10. Let's configure that. Go to configuration mode and type interface FA0/1 switch port access VLAN 10 to 10. I'll go inside interface FA0/3 switch port access VLAN 20. 4 also VLAN 20. This is a command which we have used just now. So it's a very simple command. Only one command I'm just repeating different ways. Interface, go inside the interface and tell that, hey, you are part of switch port access VLAN 2. The first one is interface FA0/1. Just for reference, I'm typing here also. Enable configure terminal VLAN 10, VLAN 20, interface FA0/1. That's it. Here is the entire command, just for reference. Here you can see the entire series of command. If you guys want, you can take a screenshot also. Fine. This one is finished. Now we'll go with the last and final lab between two different switches. Okay. And I'll show you what if I have two different switches. I have to configure trunk port between them, right? So let's keep it here only. Just if you guys want to configure a copy, you can copy from here. Okay. For two different things, I'll just take Two more switches, PCs. Here also I'll take PC. And we got a switch, one switch and two switch. That's it. Okay. Now what I'm going to do, I'm going to make the above as VLAN 10, below as VLAN 20. But I will show you without trunk, the ping will not work. And with trunk, the ping will work. I'll use same set of IP here also. 10.001 here, 10.002, 10.003, 10.004. So I'll configure FA0/1. Here it has VLAN number 10, 2 as VLAN number 20. Same command only. VLAN 10, VLAN 20, FA0/1, switch port access VLAN 10. Here also I'll do the same thing. FA0/2, part of VLAN number 10, 3, VLAN number 20. That's it. Let's wait for the link to come up. And once it comes up, if I try to ping, by default, the ping will not work. This is because the FA0/3 and 1, they are also part of VLAN number 1. They are not the trunk port. Simple. Now if I configure this as trunk, then it will work. To configure a port as trunk port, just go inside the port and type switch port mode trunk. That's all. If I configure the port as trunk port, this is a one simple command. You have to go inside the port and you have to configure this. Let this come up. Now if I just go back to my same PC, I'll try to ping. Now the ping will work. So that's the power of your trunk port. So apart from this logic, I just configured one simple line of command that goes like this. Interface FA0/3 Switch port mode trunk. That's all. Fine. That's all for today, guys. If you have any questions, please ask in chat. Thank you.